This week on QDL, we're going to look at two pieces of equipment from Nikon Metrology, a manual microscope as well as a vision system, and we're going to look at CMM Manager software, which works with both of them and a wide variety of other Nikon equipment as well. So don't miss that. Come back with us in 30 seconds. Welcome back to Quality Digest Live. QDL is your weekly look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest, and today we have a Tech Corner where we're going to look at two pieces of equipment from Nikon Metrology, an MM800 manual microscope as well as their iNexiv vision system, and we're going to look at CMM software that runs with both of them. It's called CMM Manager, and here to present all that to us today is Nate Frost. He is the Product Manager of Application Software for Nikon Metrology. Nate, thanks for joining us today. And what are we, well, first of all, I guess before we get into the software, because that's really the main thing we want to talk about today, right in front of me is your one of your manual measuring microscopes, right?
Right. This is a Nikon MM800. These systems are typically offered with some sort of digital readout, mainly for doing manual measurements using crosshairs. So today we're actually looking at this system with CMM Manager software. So we're interfacing to the scales on this much like we would with a traditional CMM. And then also with a digital camera, we're able to perform measurements in the traditional sense with crosshair, but also with edge detection and pattern recognition and all of the bells and whistles that you normally get on the motorized systems we've enabled on these manual systems.
I guess we should point out, because kind of a key thing is, by its very name, CMM Manager, this started off actually as software that worked with traditional CMMs, right?
Right. So this is a retrofit software, a software retrofit. So we're able to plug and play to just about every CMM that you're familiar with purely through a software interface. So a lot of our users are maybe in a situation where over the years they've purchased several CMMs of all different varieties and brands. And what CMM Manager allows them to do is unify to a single software platform on all of those CMMs, portable arms, and now, of course, the motorized iNexiv systems. And finally, very recently, we've added support to the Nikon MM measuring microscopes.
So if you're familiar already with CMM Manager, then you can switch equipment, keep with the same software. You're already familiar with the functionality. You're not having to learn special software for a vision system,
exactly,
and then a different software for a microscope, and then different CMM. Okay, all right. So tell us a little bit about CMM Manager and what it does.
Yep. So with the software-based solution, we can do things that you might not normally do on these measuring microscopes. Very simple things like outputting report data to PDF or Excel or to a printer, and capturing those run results and those measurement results. So when you've got somebody using this tool for measurement, but they also have to keep historical records of their measurements, that can all be realized through the software solution. So beyond saving data and then also importing data, like CAD data can be imported into the software in the same sense that you would with a traditional CMM. We can do alignments and measurements and reporting against that imported CAD data. But then finally, the thing that should be really interesting with a manual measuring microscope like this is we've enabled edge detection, which is something that's typically reserved, again, for these motorized iNexiv type systems, motorized vision systems. So this edge detection and pattern recognition and all of the image processing that we're doing here allows the operator to place the workpiece in maybe a more arbitrary orientation or position on the stage, and lets the software guide them through the measurement process.
Okay. Well, why don't you kind of show us maybe on the screen here, I guess first off, how they might do like a manual, manual measurement.
So just doing a manual measurement without creating a program that you're going to rerun, maybe just for some quick walk-up inspection. You can move the machine around manually using the hand cranks or just manually moving the stage. and you can find a feature or features that you're interested in measuring. And in this case, we'll measure maybe a circle. So we're looking automatically at the edges of the circle, and just some settings here to change. So we're telling the software that we want to find a circle within these boundaries that's transitioning from black to white, not white to black. And we find all of those edges automatically. So in contrast to the traditional way that you might do that, using a crosshair and even looking through the optics on the microscope, you can see that manually moving a crosshair or manually moving the stage to register that crosshair can be very subjective, and you may get different results from one operator to another, where using edge detection gives a lot more repeatable and accurate results.
So you just you specify the field, kind of the field that you want to look in for that particular shape. Let's say a circle, so and it just automatically finds it.
In this case, a circle, but of course it could be any type of geometry that we're trying to measure. So in this case, we could also do a line measurement. So actually, with those two features measured, you can see graphically the circle and the line that we've measured, and then we could report distances and sizes and geometry on those traditional geometric type features.
Okay. Now, the one thing I thought was interesting when you were showing me this earlier is kind of the way it can be set up to guide a user through a measurement program, right?
Yep.
So they don't have to necessarily follow a written instruction. They'll actually step them through it?
Yes. So I've prepared a very simple program here. It's just aligning to the corner of our workpiece and then prompting the operator to measure a handful of features. But from our program list here, if we click the play button, immediately we're given some instructions. So on the top right corner of the image window, we see a compass, if you will, that's guiding you towards the direction of the measurement.
Oh, okay.
And then once that measurement is within the field of view, it automatically will follow the workpiece. So this first measurement that we're doing is just a pattern recognition where the software is automatically identifying that corner of the workpiece.
Now, is that to orient the part?
That's finding the location of the part for I'll say a rough or an initial alignment, but then also considering the rotation of the part. So if we run just the first couple steps of this program, you'll see these edge measurements. The orientation is automatically aligned to the orientation of the part. And if I stop this program and just replay the program, but this time we'll actually adjust the orientation of our workpiece such that it's rotated a bit.
Okay.
Now, when we go and find this initial corner of our part, you see immediately the orientation of that tool is tilted according to the orientation of the workpiece.
This gets you kind of away from having to jig parts, or they just basically got to get in there roughly. Yep. Roughly right.
Well,
right?
And even full 360-degree rotation can be accounted for. And as you can imagine, with a microscope, you could have very, very small workpieces. So sometimes it's nearly impossible to make a fixture or a jig, as you've mentioned, to hold the part in some sort of repeatable orientation.
Okay, so you've located the part, you've located the part. Now it's going to step you through the actual measurements that you need to do, right?
Right. So again, this compass is guiding me in the right direction, and I see the tool highlighted in red. The two red concentric circles is the measurement tool that's being used. So as long as I've got that lined up within the field of view, when I move, of course my workpiece is rotated now, so it's
wow. And so the operator, when they get to that point and it's done the edge detection, detected that feature, they just click a button to capture that data?
Yes. So in this case, I'm just clicking the space key, the space bar. There's options for the hardware interface that we're using that you could also use a foot pedal or a thumb switch or something. But in this case with a desktop PC, it's pretty easy to get to that space bar every time.
And then it just steps them through to the next one.
Yep.
Okay.
Yep. So when I hit that space bar, then it indexes automatically to the other arc segment of the circle.
And is it difficult to program a measurement routine?
Yeah. So the programming is really just a case where the software is going to repeat the operations that you've created. So if I ask the software right now, okay, I want to measure a line, and then I create a buffer tool on a line, I can see a preview of the points that are being measured. When I collect those points and end the collection, it's added a step now into the software.
Okay. So at each step you would tell it what type of measurement you're going to take.
Yep. So am I measuring from black to white, or I give the software some information about the contrast of the edge that I'm measuring. Typically on a workpiece you can set that once or twice on different types of edges that you might be measuring. But every setting to do with edge contrast and measurement direction is all saved as part of that program, and then could be edited. So sometime down the road, if you decide, okay, I want to edit this measurement step, just by double clicking on that step in the program, I can open that back up, and I've got an interface where I can perform some edits or make changes to the program very easily.
Okay. And when you're done, how are the results output?
Yep. So if we just report maybe everything that we've measured here, I can show an example of the different types of report outputs. So a default report in the software is going to look something like this. You've got header that you can change, and you can add serial numbers and have a prompt at the beginning for lot number or serial number or operator initials. And then this report that we see here on the screen now could be saved to PDF, Excel, several different text formats. But you could also ask the end user to create their own report template. So maybe they're getting report templates from their customer, or maybe they have some unified reporting template that they're using throughout their facility. If they can generate that file in an Excel format, there's a function in the software that will automatically output measurement results to specified cells within that Excel document. So it's really up to the operator to choose, okay, do I want to use this built-in default report templates, or do I want to take some time and use some pre-existing report document and populate the data into that. So once you spend some time setting all of that up, now every time you run that measurement routine, that measurement result is updated and the report document is updated automatically. So it eliminates a lot of this manual transposing of data or writing down measurement results that you might be doing if you're using one of these systems in the more traditional sense with just a simple DRO or a simple measurement box. Okay,
now suppose we've been talking about basically kind of a standalone measurement where we're going to take our measurements and output them. Do we have the capability to compare our measurement results to, let's say, a CAD model or something like that?
Yeah, so we can compare measurement results to either a previously measured, I'll say, master part, or of course you can import in a traditional nominal 3D or 2D CAD model. So in these particular examples, we've looked at doing line and circle and traditional geometry measurements, but you could also have a totally irregular shaped part, and you could evaluate a profile along those edges that were measured again with the edge detection and the video measurement.
Okay, so that was using CMM Manager with a manual system, the MM 800 here, and now we're going to look at the CMM Manager with an automated system, right? The iNexiv, which is a vision system, right?
So everything that we've talked about already with the MM 800, we'll be able to do on the automatic system. The automatic system, not only does it move in a motorized fashion, but it also adds a touch probe to the equation.
Okay, so let's run over here to the iNexiv and take a look at that. Okay, Nate, so now we're over here at the iNexiv. So tell us a little bit about the iNexiv, and then what the differences between using CMM Manager with an automated system as opposed to a manual microscope.
Right. So somebody might see this piece of equipment differently depending on whether they're coming from using something like the MM 800 that we looked at previously, or if they're coming from using a CMM. So the way I see this with my history in CMMs is I see this as a small CMM because of the touch probe,
Sure.
and it has a camera on it. The way somebody that is coming from like a measuring microscope might see this is it's just the motorized version of the measuring microscope.
With the touch probe on it.
Guess it's, somewhere in between. But in any case, it has a motorized stage. It has a touch probe, which is an option, and it also has a laser autofocus tool for doing Z-depth measurements, which again is optional. So by any case, you've got a camera with 3 lighting sources, and then optionally you can add different types of probing to suit the needs of the particular application.
Okay. And Z-depth measurement, that's where it steps through and focuses at different levels? So
yes.
You get a all-in-focus, super depth of field kind of thing? Or?
Well, the Z-depth measurements for this particular system are typically done by performing an autofocus at high magnification with the optical probe for metrology purposes. So what you're describing is also possible. There's a function called extended depth of focus, where you can collect a lot of different images through the Z-stroke and then make a composite image where the entire thing is in focus.
Okay.
So we can perform that function in CMM Manager, but it's not, in my opinion, really a metrology-related function.
Sure.
So what we're focusing on with CMM Manager is actually edge measurements and surface measurements, and then any combination of different probing, purely with measurements.
Okay, got it. So show us how CMM Manager differs from a manual measurement system versus what you can accomplish with it on an automated system like the iNexiv.
So similar to the measuring microscope, we'll run a program just to get an idea of how running a program works. So now it's completely hands-off, where before the software was guiding us through the measurements. Now, of course, with the motorized stage and motorized zoom capabilities, it's purely running this program that we've created previously. So the way these program steps are created, again, could be done in a similar fashion, either using the joystick or some sort of manual interactions to create the measurements. So the thing that's different will be the ability to pick from a CAD model and drive the machine immediately to the measurement or to the feature that you're intending to measure.
Oh, so you bring in a CAD model, and then you find the points on the CAD model, and then it must have to do some sort of locating first, right?
Yeah,
but after that, it can just from the CAD model just go right to whatever feature on the part.
Yeah, that's right.
Okay.
So if I come here, for example, and tell the software with a vision tool that I want to measure a point maybe on the top of this cylindrical feature, immediately the software, because I'm using autofocus, knows to change it to a high magnification, and it performs the measurement. So there it finds where that particular surface is in focus and gives us a Z value for the depth of that point.
Okay.
And then, of course, just like we were doing with the manual system, instead of using hang cranks or moving the stage manually, you can use a joystick. But then maybe the more interesting thing with the motorized system, especially if you're working on a very small part, using the joystick sometimes is not always the perfect scenario for jogging the machine around, but you can actually double click in the video window and you can double click in the CAD window to navigate the machine from one location to another.
Okay, that's cool.
So just in general, just navigating and visually kind of getting yourself around is a lot easier. You've got a CAD model to reference to, but then also maybe another example, we'll do a touch probe measurement again on that same feature that we were looking at previously. And you'll see automatically once I've sorted out, okay, where do I want these points, you get some visualization of the probe path that's going to be executed just here with the S and then the individual point measurements and the E, so that's signifying the start and the end of the path. Optionally, I can simulate that path so I can kind of even, in more detail see what I'm getting myself into in terms of the path that's executed. And then finally, if I'm happy with that, I can verify or accept that measurement. And now the machine is moving and performing that measurement. So this path planning that's done is very similar to the path planning that's done on a traditional CMM. Short of a traditional CMM having an articulating probe, These iNexiv systems have a fixed probe, and the way that you can still use that touch probe in different orientations would be to mount like a star probe or some sort of crank stylus to access features that are maybe underneath of the part, or circular features from the side, for example.
And because this software originally came from the CMM world, you've got all sorts of stuff like crash protection, crash detection and prevention, that sort of thing is already built in. So the same thing would apply here for the iNexiv if you're using a touch probe, right?
Yeah, so the nominal CAD model of the part, along with models of things like probe racks or rotary indexers or other so-called obstacles that might be on the stage, are all avoided automatically when you're creating paths.
Okay. Now, and I think I already saw you do it here, but you had if you're going to take a measurement and your starting point is within one field of view and your ending point is in another field of view, you have to traverse the stage. Does that affect measurement at all, or is it all kind of calibrated together?
Yeah, so that's all accounted for. There's a calibration that can be performed that correlates the vision probe, the touch probe, and the laser probe, all within the entire volume of the CMM, or of the vision system.
Okay.
So that's built-in functionality to the software. There's an artifact that's included with these that will calibrate both the vision probe and then also do this cross-calibration between.
And you said earlier Z-axis measurements are also possible, both I'm assuming with the touch probe and obviously and with the vision.
Yes, of course.
Okay. All right. So anything else that distinguishes what you can do with CMM Manager on an automated system that really is kind of a key characteristic, kind of one of the key features that this combination allows you to do?
So we talk a lot about path planning, and we talked about with the manual system, the report outputting and just interacting with different file types, CAD and reports and so on. But something that we don't talk about a lot, and it's a very powerful aspect of CMM Manager, is this built-in VB scripting engine that allows you, I'll say a more advanced user, to really poke into their program and fine-tune some characteristics, especially when they have parts or workpieces that have a lot of variability from one workpiece to another in terms of reflectivity, or in terms of just the general shape of the part not being consistent from one workpiece to another. So there's a VB scripting engine that really allows you to invent what you want to do in the software. You can really expand the capabilities of the software to your needs.
Okay.
That's again a under-advertised and sometimes even underutilized function of the software, but it really expands the capabilities tremendously.
Okay. Well, Nate Frost, Nikon Metrology, thanks for showing us the MM800, the iNexiv, and also the CMM Manager, which really kind of ties all of your equipment together with a common interface, a common software that people can use from one piece of equipment to the next. So a fantastic piece of software. Thanks for being with us today. Thanks for all of you for being with us today as well. If you want more information on Nikon Metrology and its products, or any products that you saw on the show today, just follow the URL underneath the player page down there. That'll take you out to Nikon Metrology's website, and you can investigate more of this for yourself. Thanks for joining us, and we will see you. Oh, and by the way, thanks for the entire Nikon Metrology crew who came up here and helped set all this up, spent all day just getting all this equipment set up here, and I really appreciate them taking the time, and Nate, obviously, for the demo today. So thanks for all of you for joining us, and we will see you next week on QDL. So long.